In this video we're making here today, we are finding zeros of polynomials. Okay, zeros of polynomials. We are being asked to find graphically where do these things cross the x-axis. Okay, so a cubic equation, right, if we have a third degree polynomial like we do here, that will cross at most 3 times. So if these are nice, pretty numbers, we are going to expect to have 3 factors. Okay, it's kind of important to understand what it is that you are expecting to get as your answer before you begin the problem. So we are looking for 3 factors, right? X plus or minus, x plus and minus, something like that. Okay, so we're changing our polynomial from standard form, as you see right here, into factored form, which has parentheses and x minuses and x pluses. Okay, or intercept form, sometimes it's called. So we're going from standard form to intercept form. So we're going to do this by using synthetic division. So we start by figuring out what numbers could we possibly synthetically divide by. And to do that, we take all of the multipliers of, in this case, -6, and we divide them by all the multipliers of, in this case, 1. So all of the multipliers, all the factors of -6, divided by all of the factors of 1. And in this case, the only factors of 1 are 1 and 1, so it's not going to look any different when we do it a second time. So let's begin by looking at the possible factors. So what are the factors of -6? Yes, we start with 1. 1 times what? 1 and 6, so plus and minus 1 with plus and minus 6. And then what are your other 2 numbers that multiply to give you 6? 2 and 3. Okay, and we have positives and negatives because I have a -1 times a positive 6, or I have a positive 1 times a -6. So there are pluses and minuses for each of your multipliers that we're going to now try as factors to see if these are actually going to be zeros. Okay, so what we're doing next is we are employing our synthetic division with each of these, right? So these are your potentials. These are going to be your possible answers. These are the numbers that are going out here in your polynomial long division. And what we want to have, if our factor is actually a solution, right? If this is a 0, we're going to have a 0 as the remainder. Okay, so that's what we are hoping to get. Anytime that we do synthetic division, we are hoping to get a 0, right? According to the factor theorem, if your remainder is 0, then this value is in fact a solution. So let's test and see. We're going to go one by one, starting with +1. Okay, so we're going to perform synthetic division on this cubic with a, right, why is there a 0 here? Because there's not an x squared term in your original polynomial. We have to have a placeholder for every term. So here we have your x cubed. Here's 0x squared. There's your -7x, and there's your -6. So if we're missing a power in your standard form polynomial, we have to have a 0 as the placeholder. Good, good, good. So now we're going to try +1. So we're going to perform synthetic division with +1 and see if we get a remainder of 0. Okay? So we drop down your 1 always. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -7 plus 1 is -6. 1 times -6 is -6. Do I get a 0 as my remainder? No, I don't. I get a -12 as my remainder, which means +1 is not a root. Okay, so now we have to go back to the drawing board and try it again with a different factor. So let's try -1. So we drop down our 1. -1 times 1 is -1. Right? Adding that to -1. And then we multiply, we get a positive, right? Multiply and get -6. and then negative 1 times a negative 6 is now a positive 6, and voila, I do in fact get a 0 as my remainder, which means that negative 1 is a solution. Okay, which is good. That's great to find a solution, but we want to write it as a factor, right? Linear components of the factors. So what factor gives me a negative 1 solution? And that is an x plus 1. Okay, because your factors and your zeros are always opposite. So if a negative 1 is my root or my 0, then I get an x plus 1 as my factor. Fantastic. So let's remember what we have left over. What do these numbers represent? Okay, the 0 represents your remainder. The negative 6 represents your numerical term or your constant term. The negative 1 is your coefficient of x, and positive 1 is your coefficient of x squared. So what we have now, in fact, is a quadratic equation that we can hopefully factor. X squared minus x minus 6. It would be okay to perform synthetic division on this also, right, with the same factors as we had before until we get one. But let's do it a little bit better because we know how to do quadratics. What numbers multiply to give you negative 6 and at the same time add to give negative 1? Positive 2 and negative 3 are your two numbers that have that property. Negative 3 times positive 2 is our negative 6. And then here we have negative 3x in the middle and a positive 2x from the outside, and those combine to give you a negative 1x. Okay, which now means we're done, right? We have found the factors from your quadratic, and combined with the one factor from your synthetic division, we now have written our polynomial in factored form, right, with linear components. So that means an x plus or minus, not an x squared. And so we're done. But one more step on your assignment says find the zeros. So if this is what your function is, what are your zeros? Right, so we get a negative 1 from our x plus 1 factor, a positive 3 from your x minus 3 factor, and a negative 2 from your x plus 2 factor, because we're setting your factors equal to 0 and solving. We set each factor equal to 0 and solve. Okay? So your homework tonight, your assignments, wants you to go all the way to the solutions. But your worksheet here, your notes, wants you to stop here at the factors. Okay, so your homework wants one more step than what we're doing right now. So jumping on to number 2, we have all the multipliers that give us negative 10. 1 and 2 and 5 and 10. Okay, so we're going to use synthetic division with our polynomial, right, that happens to be a cubic, until we find one that works. Okay, all we need to find is 1, because if we take a cubic and we factor out a linear, that gives you a quadratic. So these three terms are going to be what makes up your quadratic. So let's test all of our numbers until we find one that works. So we find that negative 1 works. Negative 1 gives you a remainder of 0. So now we're going to look at your remaining quadratic. 1x squared plus 3x minus 10. Okay, this is your coefficient of x squared. The next term is the coefficient of x, and then you have your constant. So our brains need to think every time we do a factor what numbers multiply to give us negative 10, and at the same time add to give positive 3. And those numbers are positive 5 and negative 2. Okay? Your quadratic will give you your factors, right? 2 of them. And your other factor comes from your synthetic division. So if I have a negative 1 as a root, that comes from a plus 1 factor. Okay, so then your last step for your homework is to take your factors, set them equal to 0, and find all of your roots. Okay, roots or zeros or x-intercepts or solutions, those are all the same thing. So we're skipping 3 and going to 4 here, and we're looking for all the numbers that multiply to give us 8 so that we can get some potential factors to try using synthetic division with. Okay, 1, 2, 4, and 8. So there aren't very many, but we're going to use synthetic division until we find 1 that works. So we find that -1 is a factor, or is a 0 that gives us a 0 remainder. Okay, now we don't want to go back to our original. So we are going to stick with these numbers that we have found here. No, this is not a quadratic. Remember, this is your remainder, this is your number, this is your x, this is your x squared, this is x cubed. So now we have a cubic. So we're going to use synthetic division with the same numbers, right? Use the same numbers again to see which one work on our new 4-term cubic. So we're going to use synthetic division with your answer that we got from your previous synthetic division. Okay, until we have a quadratic, right? This is a cubic, so we have to do it one more time until we get a quadratic. So we're going to go ahead and do that. We find that -2 works also. So now we have this as your remaining 3-term, which is going to be your quadratic. Okay, so we have 2 zeros from synthetic division, and then we think what numbers will solve this quadratic equation right there. Okay, so think about what numbers multiply to give you +4 and add to give -4. Those are the same, -2 and -2. Okay, so our last factors are x minus 2 and x minus 2. And it's okay that it's a double, right? We don't mind having 2 of the same factor. But our other ones come from your 0. So this -2 is going to give us an x plus 2. And the -1 is going to give us an x plus 1. Okay, so we'll talk about this a little bit later, but we're going to find out that in this case, +2 is going to be a double root because there are 2 of the same factors that go along with an x minus 2. Okay, so we have only 3 zeros, but one of them gets repeated twice. So when we remember to put a 0 in for the x cubed term, there's no x cubed here, so we have a 0. We find that +1 is in fact an x value that gives you 0 as your remainder. So then we use 1, 1, minus 14, and minus 24 with some of the other options. So we pick 4, and we find that 4 also gives you a 0 for your remainder. Okay, and now what we have left down here are the coefficients of your quadratic. X squared plus 5x plus 6. Okay, which factors to x plus 3 and x plus 2. Those are numbers that multiply together to give you 6 and at the same time add to give 5. So then our 4 contributes an x minus 4, and your +1 contributes an x minus 1. Okay, so when we have a 4th degree polynomial to start with, we do synthetic division twice before we get our quadratic. Okay, so we're doing synthetic division until we make a quadratic, and then we factor out. I guess you don't factor out, you factor your quadratic like we have always factored a quadratic. Okay, so the options come from the multipliers of 24, right? All of your multipliers of 24. And we test all of them with synthetic division until we find a remainder of 0. Okay, get a remainder of 0, get our quadratic, factor our quadratic, and then our last piece for your assignment is to solve. So +1, +4, -3, and -2. Those would be all of the zeros of your polynomial, because they give you a remainder of 0 when we synthetically divide. Okay, so our last example is one that actually has a leading coefficient, right? Notice that there is a 2 in front of our x cubed. So we're going to look for all the multipliers of 6 as well as divided by all the multipliers of 2. Okay, so when you have a leading coefficient, not only do we have the multipliers that give you the last number, we have to divide them all by the leading coefficient and all of its factors. So thank goodness that we don't have a whole bunch, because we could have a whole bunch of fractional problems. Okay, so we divide them all by 1. You don't ever have to divide anything by 1, but then we have to divide them all by 2 also to get your potentials, because we want to start with something, so we start with these potentials. Now this one, 2 divided by 2, well, that's already 1. We have 1 already as our list. 6 divided by 2, 6 divided by 2 is 3. We already have 3 as a possibility also. So we don't have to repeat. If ever when you're dividing and your fraction will reduce to something that you already have, we don't have to include that one again. Okay, so we're going to use synthetic division, and so we get a quadratic that we're therefore going to factor. So we find -1 will give us a remainder of 0. So now we have a quadratic that has a leading coefficient, 2x squared minus 7x plus 6. Okay, and there are a variety of ways that we can factor this, one of which is the AC method. So 2 times 6, right? A is your leading coefficient, the number in front of x squared, and C is your constant term. So 2 times 6 is 12, and we're looking for numbers that multiply to give us -7. Okay, and those numbers are -4 and -3. Okay, do both of those things at the same time. Now, because we multiplied by 2, we have to divide by 2, right? This is part of the method. And we ask ourselves, does 4 divide by 2? And the answer is yes. So that leaves me with an x minus 2 factor. And the other one, does 2 divide -3 nicely? And the answer is no. So that leaves me with a 2x minus 3 factor. The number in your denominator becomes your coefficient of x, and the number in the numerator becomes your constant. So 2x squared minus 7x plus 6 factors to x minus 2 times 2x minus 3. Okay, and your third factor comes from the -1 solution, which gives you an x plus 1 factor. So your three solutions are -1, +2, and 3/2 when you solve 2x minus 3 equals 0. Okay, which is one of our potentials, right? We had a potential up here of having 3/2 as an answer, and it turned out that that was one of our answers. Okay, so synthetic division. We use synthetic division in order to simplify your polynomial into a quadratic that you therefore factor, and then you can set all of your factors equal to 0 to solve. Okay, and we're done.